Oh, it's recording straight away. It did that trick to me again. Oh, hi there. Thanks so much for showing up for your math learning, everyone. Today we're learning the laws of logarithms. So we have some handouts on the front middle desk for you, things for you to practice and build this important algebraic skill. I want to take a little moment and talk about this post-midterm, the weather is beautiful, oh, I can't wait for summer thing. Hey, guess what? Next year you will have earned your summer by now. You'll already be done your exams. You'll be doing your 4 months of working and things. I'm speaking to the grade 12s. This is like the last bit of learning that's free for you. You don't have to pay for this learning. And the habits that you continue to maintain at this time, not only will you have this important content, like you're going to use logarithms in university. Not only will you have this important content, but you'll also be going into your first year with some momentum, and then you can earn your early summer, okay? We're not there yet. So he says, after having just had a nap. All right, so okay. We're looking at the laws of logarithms, so let's check in. This is important stuff. Just like we looked at the laws of exponents, logarithms have their own parallel type laws. If the laws of exponents are intuitive for you, these will feel counterintuitive for a time, and then you'll just start doing them like the exponent laws are intuitive. If the exponent laws are not intuitive, I'd encourage you to consider things like if I have something like q raised to the power r times q raised to the power t, just, oh, why is that q to the r plus t? What you do is you create something like q to the power 2 times q to the power 3. You write it out in expanded form. There's q squared. It's 2 q's multiplying. Here's q to the power 3. Is 3 q's multiplying. And you count them up. And you're like, I can see why I add the exponents. You'll want that base level of understand the thing you're doing. Rather than just like blindly applying the exponent law. Similar thing here for logarithm laws, but I'm going to reference back to exponent laws when we talk about them. So the first one is the product law. If you're taking the log of something that has a nice clean factorization that you can make use of, you can separate that. Log base a of xy is equal to log base a of x plus log base a of y. Let's see why that is. If we have a raised to the power r times a raised to the power s, okay, and I am saying, okay, this is r over here. That's the exponent that we need to raise a to become x. And then this is s over there. That's the exponent that we need to raise it to become y. Okay? Over here, we add those exponents. This is a to the r plus s. So that's why you see the logarithms, which are the exponents brought down to the baseline. That's why you see those logarithms being added together. It's the inverse of that add the powers together law. So we can use that to bust stuff like this apart. This one, log 2 of 3a. This is the same thing as log base 2 of 3 plus log base 2 of a. We just add those together. And then this one you can actually calculate. Your calculator is going to tell you that you have to raise 2 to something like, I don't know, what is that, like the 1.5 or something? It's close in there somewhere. Anyway, that's just a number. So to evaluate that, no, I'll show you how to evaluate that later. All right, now over here, log 5 to the 2 plus log 5 to the 8. Here, you're going to say, well, that's the same thing as log base 5 to the 2 times 8. We're adding the exponents here. The logarithms are the exponent. And so that's when we have like the product of those two things. So that's log base 5 of 16. Carrying on. Next log law. All right, the quotient law. Again, if we take something like a to the r and divide it by a to the s, expanded form would show you that that's a to the r minus s. Well, in this case, this is like the thing that, this is the exponent that I need to raise a to become x, and this is the exponent that I need to raise a to become y. So that's why we have a division of those two things inside the logarithm. That's like a to the r over a to the s is what this is written here. Okay, so let's see how that works. Over here we have log 2 of x on 4. So that's the same thing as log 2 of x minus log 2 of 4. Note, division, like subtraction, is sensitive to what order you do things in. 5 minus 8 is not the same thing as 8 minus 5. The same way as 16 divided by 4 is not the same thing as 4 divided by 16. So that's why we're seeing like the sensitivity here, it's non-commutative, whereas up here, we're insensitive to order when we're adding, and we're insensitive to order when we're multiplying. So you can use those to help remember what to do, but it also opens up the possibility for error here. We want to make sure that the one that we're dividing by is the one that we're subtracting. Okay, and then there's more that I can do to simplify this. What can I do? What can I still tidy up here and make simpler? With this part.
Can you just put it into the exponent form?
Putting into the exponent form is tricky because this is the exponent, right? The exponent is sitting there and I need to subtract that exponent from the other exponent. But I can just evaluate it. That's like there's nothing in there. I can evaluate it, and I can evaluate it without a calculator. What power do I need to raise 2 to get 4? 2. This is just 2. Okay. This one over here, similar idea. We have, this is log base 8 of 5 divided by 3. Put the argument of your logarithm in brackets just to make that tidier. Hayden, do you mind grabbing the door? Okay, so that is the quotient law for logarithms. Power law, this one, you're going to use this one. This one is the one you use the most. Okay, so for those like non-math majors, this is going to be something that you're using a lot to find the exact value of your exponents. So if you recall in grade 11, we encourage you to guess and check or graph to find the value of a missing exponent. This allows you to take a missing exponent and move it down to the same line so that it's now a multiplication level instead of exponent level, and then we can continue to manipulate the equations. So, and we use this, this is for the situation I just described, so let's go take a look. Here, if I have something like this is the same thing as saying the log base 5 of 2 raised to the power 4. And then I'm not done. I can still simplify. This is log base 5 of 16. So that's how that would work. If I have this one over here, well, that's equal to this 5 just comes down. It's 5 log base 7 of x. I've been talking about why these work, so let's take a look at why it works. I'll just pause there in case you want to note. Okay, so here, when we have something like a raised to the power b, then raised to the power p, we end up multiplying the exponents, right? So this here, that is like b right there. Okay. This thing is the exponent that you need to raise a to get this value x. So when I'm raising that also to the p, well, that would be the same as multiplying the exponents here. A times bp, just multiply the exponents. So that's why this one can just multiply that exponent there. All right. The last thing that we're looking at today is changing base. Okay. Generally, a normal calculator, one that would be on an approved university list for like, yes, you're allowed to use that calculator on this test. No, you're not allowed to use this calculator. Check very carefully at the beginning of your semesters next year for all of your math classes. Am I allowed to use this calculator or not? And get one that you are allowed to use and learn to use it before the test. Okay. So anyway, generally they only calculate common logarithms in base 10 or the natural log, which is base e. So that's log e, which is written as ln. Okay, natural log. When we need to calculate a logarithm with a different base, okay, so like let's say we need base a here, then we can just do log base b, log base anything. It's just this common base that we have between these two logarithms. You have the argument of the logarithm, you take the logarithm of that, and then you take the logarithm of the base. And that allows you to change bases and evaluate things with a calculator. On our test for this unit, there's only one test. It will be a calculator test. But if you have a fancy calculator that calculates logarithms that are not in base 10, like you can change your base, I still want to see this. I still want you to show this algebraic argument. That way, I am confident that you have this skill for next year when you may or may not be allowed that calculator on a test, and you just generally know how this logarithm law works. So have this written down in your work at somewhere. So like if I wanted to evaluate log base 2 of 50, well, I just take the common log of 50. That's the exponent that I have to raise 10 to in order to get 50. Sorry, log 50. All right. And then I'm going to divide that by log 2. And when I do that on my calculator, it looks something like this. So I've practiced with this calculator, and I still make mistakes, but I notice when I make a mistake. On this one, I have to type in 50, and then take the log. And that's the exponent that you have to raise 10 to get 50. It's 1.7 or so. Okay. I divide that by the logarithm of 2. This is the exponent you have to raise 10 by to get 2. It's about 0.3. I complete the division, and it tells me it's 5.64. So we'll call that 5.64. Okay? And now I do a quick sanity check. Okay? I'm going to sanity check my answer. Sanity checking my answer is going to help me get marks on the test because I'm catching errors, but I'm also building my understanding. And that's the more important thing. When I take 2 and raise it to the power 5, that gives me 32. Okay? That's clearly less than 2 to the power 5.64, which is ostensibly equal to 50, which is also less than 2 to the power 6, which gives me 64. Okay? 50 sits in the middle of these three numbers, and 5.64 is quite believable from that point of view. So just do a quick sanity check and make sure things work out. I happen to know that 7 to the power 3 is 343. It's very close to 400. So I'm already expecting an answer before I go into this one. That makes it like a video game for me. I'm like, ooh, I wonder how close it would be. What would you think? 7 to the power what would give you 400? Let's have some guesses. Huh? 3.3? Cool.
3.25.
3.25? Anyone want to go lower or higher than our two guesses so far?
3.31.
You can only have one guess, dude.
I'm going to go with 3.1 just to...
Okay, all right, fine. It's just the two of you duking it out then. All right, so my formulation here is I take the logarithm of 400. That's the exponent I have to raise 10 to get 400. And then the log of 7. Okay, and then I evaluate both. 400, I'm expecting a number like 2.3, 2.6, oh wow, divided by 7, and I take the log. This one's going to be like 8, yeah, 8 something. Yeah, there we go. And I push equals is 3.01. Oh wow, 3.01. So it's like 3.08. 3.1, 3.08. Okay, and that passes a sanity check. It's a little surprising that it's so close to 400, but when you look at 7 to the power 4, it really does balloon up quite a bit. Okay, last one. Log base 3 to the 20. What power do I need to raise 3 to get 20? So log 20, that's going to be a number like 1.1 or something. And then divided by log 3. Why? 20, I take its log. 1.3, exactly, that was very good. Okay, divided by, is that what I said? I don't know. Divided by 3, and I take its log. It's going to be like 0.4-ish. Yeah, there. Equals 2.7. Okay, so 2.73. Again, this passes a sanity check. You don't need to write out your sanity checks, but just check it. 3 squared is 9. 3 to the 3 is 27. 20 sits in the middle, in the same way 2.7 sits in the middle of 2 and 3. It's not going to sit in the middle like linearly the way it does, because one is multiplicative and one is additive when we're looking at the scales, but that's kind of an idea for tomorrow. Okay, and there's a summary of our different rules. So at the end of the lesson, I'll leave that up. I encourage you to practice the delta math that just dropped, the laws of logarithms. Skip the problems that involve e. Those you can skip, or you can learn them. You can ask me how to answer those, and I can help you. Probably it's just with Lon. And try these in the textbook, and try the front of your handout there. The rest of the handouts are for tomorrow on other stuff. Okay, so I'll leave this up, and we'll pause there. And thanks very much for showing up for your math learning.